Welcome. We're going to continue our explorations with line of best fit. In this case here, our problem talks about Calvin collecting data for the number of days that he's been reading a book that was 350 pages long and how many more pages he has left to go. So the question asks us, how many pages of the book will Calvin have left to read then on day 15? Now, when you look at your data and your information, we have information about his reading from day 2 through day 12. I don't know anything about day 15, so we're going to try and make a prediction for what we think this will be. I'm going to do this with the line of best fit, and I'll have our graphing calculator do that. So I'm going to use my first entry line, click the plus sign to add in a table of values. Now recognize that your table is given to you here in a horizontal format, but it's only going to go into Desmos in a vertical format. So we're going to recognize that days are the independent variable, that's my X, and the pages remaining in the book is the dependent variable, that'll be the Y. So we'll enter those into our calculator. 2, 3, 5, 7, 9, 10, and 12 for my X values, and then my Y values are 309, 292, 249, 190, 155, 143, and 106. And I'm just going to double check, make sure that we've got them all there and typed correctly. Notice I can't see anything on my graph right now, but do recall in that left-hand margin, your zoom fit is that magnifying glass in the entry line, and that lets you automatically get your scaling appropriate to see these points and where they are. So they look like they're following a line, but not quite. There's a little bit of a wiggle in them. So we'll get that line of best fit written. Remember that this is based on the y equals mx plus b idea. So we type it in almost exactly like that. Instead of y, we use the y1 from our data entry field. Instead of the equals, we do that squiggle with the tilde. M is my slope that's going to stick around. Instead of x, you go with x1 and then plus b to finish that out. Now take a look at your statistics. My R2 value is a 0.99. That is really, really close to 1. This is an awesome R2 value. That says that this line is a really, really good correlation. This is very strong, and so it'll help me make accurate predictions. I can keep on scrolling down to my parameters. I get my M value. It's a negative number, and that makes sense. The number of pages that are remaining is decreasing as we go along, so I would have a negative slope. And I get my B value. So use these, and we plug in then to our equation. So y is equal to my M value as that negative 20, 0.9, and now I've got 0.948, so my hundredths place 8 tells me to round up, so I'd get a 0.95, still with my x, and then my b value plus b here, plus 349.93. So this would be the equation for my line of best fit, if I wanted to know what that equation was. So think about this M value, my slope, this negative 20.95. That slope says that we're dropping about 20 to 21 pages each day, right? That's my rate of change is the slope. And then my B value is the y-intercept. So what does that y-intercept mean here? That's talking about day 0. So at day 0, how many pages are left to read? Well, it was a 350-page book. So does it make sense that at day 0, at that y-intercept, we'd be at 349.93? Yeah, that's a really good prediction. My y-intercept lines up almost exactly with how many pages I knew were in the book for that correlation. Now, however, we still haven't gotten to the question here that was asked of us, which is how many pages are going to be left on day 15? So what do you know about day 15? Day 15 would be an x value. So you're going to use this fantastic line of best fit equation and replace the x with that day 15 that we care about. Take x out, put 15 in its place. So negative 20.95 times 15 plus 349.93. That's going to give me a y value. Let's find out what that is. We're just going to go ahead and plug this into our good old graphing calculator. and it comes out with 35.68. So my y value, 35.68. Now y is talking about the pages remaining. Can you have a partial page remaining? No, you can't. We're not talking about like a half of a page for that. So we're going to go ahead and round. This would be about 36 pages remaining. So you can do this for any amount of data to be able to make a prediction for something else that might happen within that date range. I can do it for day number 8, even though it's not printed here. We could predict how many pages at day 8 remaining, or we can predict into the future beyond what we have recorded. So you're just going to be using that line of best fit equation, get the regression out of your Desmos calculator, and then make a substitution and evaluate with that arithmetic. Wishing you lots of luck.